Alright, welcome back to the channel. In today's lesson, we are diving into object-oriented programming in C#. This is where you start thinking like a professional software engineer. We will cover classes, object, and one of the most critical concepts, heap versus stack. By the end of this video, you will not only understand the theory, but also see practical codes and examples as well. Now, the question is this: why object-oriented programming? Now, imagine building a banking system using only variables and functions scattered everywhere. That would be chaos. OOP exists because real systems are complex. It helps us organize code logically, model real-world system, and make maintenance easier. And yes, it's the industry standard. Now, what is a class? A class is just a blueprint. Think of it like a house plan. It defines structure but doesn't build the house yet. Now let's go into our code and understand more. I'll right click on this project name, then file, then click on class, then I will give it a name. So let's name it student class. Let's just say student class is being created now. So I have this as a standard. It comes out and give me the student class. So I'm going to say public. Let's say public string. So I'll say name. Sorry, I'm going to explain this. I'll say name. Then I also need a method for this class. So I'll say public, then void, meaning that this method does not return anything. So name. So this will print just the name. So then CW. I hope you remember that. I don't need this just because we already imported that system at the top. System is imported at the top. So we can say student name is then you remember concatenation. Then we can concatenate the name variable that we've created before now. So if you look at what is going on, the first line of code says we define a blueprint called student. So this is a blueprint called student. Then inside this student class, everything inside define what the student look like. Then here basically a field, it is known as what? Field variable inside the student class. Why this one is a method inside the student class. Then this is what we print the student name to the console. Another question is this: what is an object? So an object is a real instance of a class. Now the moment you use the keyword new, memory is allocated and the object comes to life once you use the keyword new. So basically, when you are creating an object, let me just give this. When you are creating an object, let's say for instance, want to create an object of this class. So we could say student, then let's say st1 equals to new. By the time once you specify this keyword using the new keyword, it means you have allocated a memory on the heap. You remember we talked about heap versus stack on the heap. Now we are now going to use this. Let's say for instance we have this now. So this is a complete line of code to create an object. Now when we say okay, I will still comment this. So let's say st1 dot. So when we say st1 dots, and then we are now assigning value. We use this to do or to assign value. So we can say name, can call the variable name and say equal to. Then we can now assign value to this. We can assign value to this. So basically, this is how you assign value. We are going to do all these things inside our practical section, but I'm just trying to explain this. When you do this along the line while creating an object, you are assigning value to that reference variable. So don't forget, the reference variable is stored in your stack. Everything you create, they are stored in your stack. Why the object itself is stored in what? The heap. Why the reference, this is a reference variable which is st1, is stored in your stack. Then let's talk about heap versus stack, or stack versus heap. critical concepts. I call them critical concepts. Now, this is where many beginners get confused. A lot of beginners get confused when it comes to heap and stack. This is where many beginners get confused. The stack stores simple values and references. It fast and automatically clean when method finish. So when the method finish, when you finish using that method, it automatically clean. Now, the heap stores object created with the new keyword. They stay there until the garbage collector remove them. Remember, the reference lives on the stack, but the actual object live on the heap. Don't forget that. The reference live on the stack, while the actual object live on the heap. So let's say, for instance, we have something like this. Let's just say int x equals to 10. So let's say int x equals to 10. So this one is stored on the stack. But when we say something like this, student st1 is equal to new student. This reference is stored on the stack, object on the heap. This reference is stored on the stack, while the object is stored on the heap. Don't forget, the object is a real entity that is created from a blueprint from the class. Don't forget. So if we have something like st.name equals to Omoefe become the real object because it represents somebody, it represents person. Why the st1? It is not the object, it is a reference variable of that object. So if you want to see that object, use the st1 to call that object. Let's go into encapsulation. But don't forget, reference lives on the stack, but the object is on the what? Is on the heap. Don't forget. So encapsulation is among one of the 4 pillars of OOP. Now, encapsulation means keeping data and the method that operate on it together. Instead of exposing raw data everywhere, we control access through method. Now, this is how professional systems stay stable. Now you can see, if we want to view this variable, the data inside this variable, the value inside this variable, we have to call this method. So in other words, what we are doing, we have encapsulated this method. Now let's say, for instance, I will create another. I'm going to create I will create another class. Let me do this bank account. So should be created this way. So we have our bank type private. This is access modifier, private double, then balance. Okay, so this private variable, they are called, you can refer to them as what? Hidden data as at this point. So I'm going to create another method again. This method is going to be the one to expose what is inside our private variable. So we'll say deposit is going to receive one parameter, amount. So amount going to receive one parameter called amount. So I will do this. So let's call our balance plus equal to. So when I say the word plus equal to, I'm saying do not remove what is inside the balance already. I want you to add what I'm adding to it now. So it's not going to clear it, is to just update what you have there. So we also have another method called public double. Then let's say get balance. Yes. So get balance. Then we just say return balance. That's all. So now this is what is happening here. The private double balance, which is here, is what? Data hidden from outside. So it means that outsiders cannot what? Outside classes cannot access that. Yes. Now we also have deposit method, a method called deposit. Now this method has one parameter, which is amount. Now there comes that concept of encapsulation. This encapsulation controls how balance changes. Now we also have get balance. Get balance is a safe way. To access the balance. This is a safe way to access what? To access the balance. The get balance. You can see. Even the deposit balance is a safe way to deposit something inside the balance. So in other words, what we are doing, we are encapsulating We are encapsulating the important stuff out for the outside intruder not to go in easily. You must pass through some protocols. So if you need to update the balance, you have to pass through. You have to pass through the deposit method. While if you need to get information from the balance, you have to pass through the get balance method. I hope it's clear. Now, the next concept is abstraction. Abstraction. The question is, what is abstraction? Abstraction means the user doesn't need to know how something works. They only need to know what it does. So the customer does not want to know how this thing is working. It's none of his or her business. They just want to know if this thing is working and if this thing is doing their job for them. No matter what you explain, it's none of their business. So I'm going to create another class here. At this point, it is called an abstract class. So I will say class. So let me name this. Let me just name shape. Let me name it shape. So I have a class called shape. So yes, this is it. Public, but here I will name it abstract class. So this is an abstract class. Now this abstract class, it's going to have an abstract method double. So double, then area. So this is an abstract method. So below it, I'm going to create another class again. I'll create another class here. So I'll just say public class. Then I will say circle. So this circle class is going to inherit the abstract class that we have above. So then we can make use of the method that has been created before. So it's showing this red underline, letting us know that I say circle does not implement the inherited abstract member. So letting us know that there are members in that abstract class that we need to inherit in our circle class as well. So these are unimplemented methods. So we are now going to say private double radius. Let's say radius. Then we have public double, public circle. Then this one is going to have double. So radius equals to arrow. So that is one method. Then another method. So here, this is where we are going to remove that error. So we are going to overwrite. The area. So let's see the area. So we are overwriting the area. So you can see that the error automatically got erased. So we can now say return maths dot p. Okay, so then radius multiply radius. Yes. So this is complete. This is what is known as what abstraction in C#. It is as basic as simple. It is simple. Try to understand it. You don't need to start going into the complex ones. Understand these basic ones, and you will know the foundation of creating abstraction in C#. Now, you can see the first line. Let me go through again. The first line, abstract class shape. This defined a contract. It defined a contract, which is what area method. Then the next one, which is what circle inheriting shape. This one is what implement the contract. So this was where we implemented the contract. This was where we define the contract. This was where we implement the contract. So here we provide actual logic for the area. This is where we provide actual logic for the circle or the area for the circle. Developers don't think in variables, they think in entities. If something exists in the real world, it deserves a class. It deserves a class. Now, let's say for instance, let's create another class. Sorry, I'm creating a lot of class. I want you to get used to this. Create another class here. We're going to create another class called employee. sorry, employee, create another class called employee. So I have employee class here. So this employee class, we will have something like public string data type, then employee name. So this one we hold employee name. Then the next one, public int. This one is going to hold employee ID. Sorry, public. So this one is holding employee ID. Then why we have the next line method, let's create a method. So void means it's not going to return anything. Void work. So this is a method work. So all we are doing here is console dot write. So console dot write line. Then when you do this, you can now say name plus, it means you are concatenating. Don't forget, is working. So you are saying Jude or John is working. So any name that is here, you are saying the name should appear here and say Jude or John is working. But basically, how do you do that? You can do that by what? By calling this method. So that is an idea for object-oriented knowledge. So the employee, I explain again, the employee represents a real world entity, while the name and ID, they are known as what property of the employee. The method himself, which is work, the work himself, it is the employee behavior, what the employee class is doing. We want to create a student management application. Now here, a simple student management application, it shows how classes and object work together in a real system. You can add, remove, and display students, all encapsulated nicely in classes. So I'm going to create this. Very simple. Let's say for instance, I will just create among this and do this. So the first class is student as the first class. I think I have that class already. So I have student class already. So all I need is just to use the student class that I have already. I'm going to remove this save. So I have student class already. So all I will do is student class. I will remove all this. So then I'll just say public, exactly what I wanted. Public int, then ID. Then we have get and set to get the ID, and also to do what? To set the ID as well. Public string student name. So this one also have get. You can the first line is to get the student ID and set the student ID. The second line is to also get and set the student name. Then the next line is for us to initialize. We are going to use a concept called constructor. So we're going to say public, then public. The constructor must have the same name as the name of the class. So public student, then we have int ID, then string name. So this is a constructor. So the constructors are used to initialize the class or the members of the class. ID equals to ID, then name equals to name. So everything is working. So the next one, so this is a constructor. So we have used the constructor to initialize. Then we can now say public. Let's create a method. Public void display to display everything. So we can now say, let's say this w. So we say dollar can display our ID, then comma, then we'll say name, then this can display our name. So it's showing error because the name we are the ID we are displaying is different. So we need to display the ID inside the constructor. So the ID inside the constructor. So I'll still come here and create another class again. So it's here. So student manager. So inside the student manager class, I will have private private list. Let's use list here. So to list, so list, then I'll say student, is plural. So student, then new student. So now let's add students. Creating a method to add students. So we can say public void add students. Public void add students. Then we can say student, then student. So we are using the student class as a reference data type. So this. So you can see here this sorry, something is missing here. So let's student. Okay. So now let's say student, which is the reference type that is stored inside the stack. Student dot add. Sorry, it's supposed to be okay. So if you now say student dot add, so we can now add students. So let's say add student. So CW, I will say student, then student dot name, which is correct. Student dot name. So you can say student added. You now put the name of the student, so it will display the name of the student that was added. Then the next one. So let's just I think we should just name it well. Just come here and say something like that. Just so be. Just say okay. So I'm trying to use comment to describe what. So let's say public void remove student. So you say int, then you want to remove the student using the ID. So you just say then student dot remove. There is a method called remove all. Yes, remove all. Then remove all. Now let's say x. Let's say x. If for those of you that does JavaScript, there's what they call arrow function. So x, then to x.id is the same thing as id in as much the id is the same thing as the id that has been entered. It's removed immediately. So CW, then we do this. Then we say student with ID. Then you are listing that ID with ID removed. So that is it. Then the next one, let's say display all. Yeah. So just put this just for description. Also mini description student list. So just say student list. Then you can now use for each loop. You can refer to other lessons about some other lesson about loop to understand loop. So I'll say far. Then so let's say students in students. So now control has been passed to this variable here, student. So we have everything there. So all we need to do is to say student dot display. That's all. student dot display. That's all. Then then let's go to this place. Let's go to this place. Then we're going to create public, let's just say public static void main. Now this is the main method. This is where and it is called entry point. Look for this method to run all our methods. So you can see so let us first of all create the student manager first. Student manager, then we say manager. So we talked about objects, creating objects. So this is an object of the student manager class. This is an object. So we use a keyword, we use a new keyword. Don't forget a new keyword to allocate that memory. What's this? New keyword. What is going on? Okay, it's already there. New keyword. Then we say student manager. That's it. So when you have that, the memory has been allocated. So all you do now is to say manager dot add students. So you have add students there. So we can now say, so I'm going to do this, and I'll say new. I'll say new. So this is how I create the student class. So student class, new student. So I'll give the ID 1, then name. Give name here. So we have this now. So I can duplicate. It, and I just okay. So I have 2. So I could just come here and say 2. Let's say 2 in Joseph. So if you don't understand anything, reach me at the comment section. Just chat me up at the comment section, or just comment. Just come here and say manager dots. So display all. So this is the display all method that I created. Then display all. Then also manager dot remove. You can say remove student. So you can say just specify one there. Remove student by ID. So you want to remove that student. So let's test it. After removing, what you will get. So let's say something like let's just say display all again. So it's assume I removed everything there. I want to see what is there again. So let's run our program. Let's run our program. Okay, so run it. Let's open with Git patch. So I will say .net run. So let's give it some time. It's going to run. It's compiling. It's going to run. Okay, good. So you can see it. You can see what is going on. Student Omoife added, student Joseph added. Then student list is ID 1, student name Omoife, ID 2, student name Joseph. Then student with ID 1 removed. Then list, it now display this. So thank you, and this is lesson 6, and it is being completed. You still have a lot to learn. If this lesson, you learned a lot from this lesson, smash the like button and share this video, comment, and also subscribe to this channel so you can get more updates. This series is about to finish and we are in lesson 6. Thank you for watching and stay tuned.